So we have come a long way to learn about the very rich but very structured and layered data types in Python. So the four basic scalar data types, boolean, int, float, and string, and the four composite, that means with some structure, data types in Python, the list, tuple, set, and dictionary. We also have seen some examples of the comprehension setup, list comprehension, tuple comprehension, set comprehension, and dictionary comprehension. And now comes the exciting part. Can we create our own structure? And the answer is yes. Python has a very neat, simple way to let us do that. And the keyword is class. Now, you may have heard of object-oriented programming and classes and all that stuff. And all those are kind of true and kind of not complete or not exact in Python. The way we want to talk about class here is from the angle of creating our own data type, creating our own structured data type. What do we mean by that? Suppose I want a type that is more reflective of my real world application. For example, I'm writing a company application, company processing application for human resource about employees, about their contribution to companies, about their educational and skill qualification, about their training completions, about their salaries, about their promotion and all that. Okay, so it's a complex system. And I want to reflect employee as a structure, as a data type. So employee is a data type, and the data value is the actual employee. Does that make sense? Right? Because a person, a human, is not necessarily an employee of that company, and if they are properly registered, there'll be employee ID. Right? So I want this structured data type to be called employee because then it makes more sense. Can I do that? Answer is yes. So of course I'm giving one example of many different examples, but just scroll down with me for now, right? Definitely class is also used in object-oriented programming, which definitely deserves its own 2, 3, 4, 5, 6, 10 sessions maybe, a lot to talk about. But here we are borrowing the class to create our own data type. That alone is already very powerful. So how we go about doing that? And basically, we are just making a superficial initial contact with the keyword class to create our own employee data type. And the way we do it is very simple. Once you have a class, you give it a name. So of course, we exercise our right to call it something meaningful. And notice that class names, this is for the name of a new class that we are creating. It's not called structure, it's not called type. But when we create a class called employee, we also have a type that's going to be called employee. So what are the values? So when we say class employee, we want to describe what are the values that are contained in this type called employee or in this class called employee. The way in Python to do it is simply defining a method function. It is a function within a class. So a class here is not a function because it's not going to be executed. A class employee here is also not a, how should we put it? Not a variable. It's not it's nothing. It's a class. And it is not called a structure because even though we are using class here to create a structure, a class is more than just a static bunch of data values. It is able to have a function as what we see here. So we are using this function to initialize the class. You definitely have to do that, right? So that whenever we call this function, and when we talk about class, we don't use def, we use class. So when we kind of call the function called employee, the syntax looks like calling a function that is named as employee. And it also feels like we are having a def here. We are defining a function called employee here, right? When actually not. Python treats this very, very uniquely differently from just a function. Why? Because when we use the class name bracket, we are supplying a bunch of basic data. Why is it basic? It's basic to the employee. How do we know that it's basic to the employee? Well, we are designing the data type called employee here. So my employee in this program will have first name, last name, and the company title. That's all. And of course, with your imagination, you can think about date of birth, salary, current educational level, and so on and so forth, right? We just keep it simple for now, but your imagination is the limit. So anyone who wants to create a data value, remember data value? An integer data type has a data value of 3, 4, 5, and any integers, right? So same thing, a data type called employee data type. What are the values? Well, the values will be a bundle, a class instance, that's the more official name. An instance having the three entities of data, subdata. So first name, last name, and company title. Any employee data type or employee instance must have these three bits of data. So that's the design and the definition of employee. It's completely up to us. Completely up to us. All right. So on creation, on birth, we need to first supply the ingredients for it to be created. So therefore, we must supply first name, last name in that order because it was listed first name, last name, then title. If we want title first, then we bring title first. Then all creation instances of employee must have the title first. This is how we design the new data type called employee, right? So by using the class here, by borrowing this very powerful keyword class, right, and using the initialization method function, we have to use now the word method instead of function, even though it's DEF. That's where Python starts to overlap and ignore certain stringent object-oriented definitions and all that. So it doesn't matter. We just go along with Python's way, which is more straightforward, practice oriented, and very, very useful in terms of going straight to the point, no nonsense, and getting the job done. So we definitely have to define the initialization method in that manner. The self itself is a must. That's where function methods within class differ from function definitions within functions. Function definitions, we can have DEF within DEF, that's fine. And we don't have to have self. What distinguishes the sort of class methods will be the presence of this self here. Self refers to the particular instance of employee that has been created. So for example, John now is a self. That means we want to say John's name. So John's name, John's first name is going to be this assigned John. John's, because you see, the next guy, William, is also going to be created by the same fashion. Employee, William Smith, Senior Vice President. So this self is going to be able to distinguish between John's self, that instance, versus William's self, the other instance. This self is not the same as that self. So self always refers to that particular creation object, that particular instance, that particular self person, right? So that person, that self has a first name, this first name, given first name, and so on. So we created that structure. Up to here, it's just a definition. There's no instance yet. There's no data yet. There's no data of data type employee yet. Here, we now create, if we instantiate the first instance of employee, and now it's a data. It's occupying memory space. It's real, and it's going to be named as John. So for convenience and ease of reference, we call our variable John as well. Although here we can call it ABC or XYZ. Then we print what's the value of John, but let's just run it and see, right? It'll be easier to just run it and see. Okay, let's run it.